The ECOGIG Consortium is focused on a range of questions. The overarching one is, what is the role of hydrocarbon inputs in shaping biological responses in the Gulf ecosystem? Because there are a lot of natural seeps in the Gulf of Mexico. And we're really interested in learning how natural hydrocarbon seepage affects microbial communities and biological communities in general, everything from microbes to zooplankton to deepwater corals. And then the other part of that question is anthropogenic oil spills and anthropogenic oil inputs. How does the community respond to natural oil inputs versus anthropogenic oil inputs? It's important in the context of the oil spill, but it's also important just practically speaking for basic scientific reasons. And that is that what we're studying is the fate of oil and what regulates the fate of oil and gas in the ecosystem. For example, there is a whole slew of microorganisms that can oxidize and consume oil and gas and assimilate it into their biomass, and then you can have zooplankton and fish that essentially eat the hydrocarbons, but the microorganisms detoxify them. So in the case of a blowout like the Deepwater Horizon, how much of that oil and gas was consumed by microorganisms and moved up the food chain. We know that a good deal is, but it's really hard to constrain that because we didn't have the density of measurements that we needed. At natural oil seeps, we have an analog where we can really do controlled experiments under very, very known conditions and look at how various environmental factors, where the water's going, how fast the currents are, what nutrients are available, how that limits or accelerates hydrocarbon degradation and assimilation. And one of the biggest things we're interested in is how much of those hydrocarbons are assimilated into biomass versus turned into carbon dioxide. Because carbon dioxide obviously is an acidification agent in the oceans. So it's much better for them to assimilate it because then you feed fish, but you detoxify the hydrocarbons in the process. So we spend a lot of time at sea, about 4 months a year, I think. And we deploy instruments on the seafloor to measure fluxes out of the seabed. So we really have an approach that's holistic. We work from the top to the bottom. We use satellite remote sensing to look at oil slicks on the sea surface to document the variability in seepage regimes across the northern Gulf. We take our instruments and put them on the seabed, and we quantify fluxes of oil and gas from the seabed to the water column. And then we go out on cruises where we measure rates of activity and inventories of carbon, nitrogen, phosphorus, hydrocarbons, et cetera, in the water column. So all these things, when you connect them together, allow you to get a really good idea of the fate of these hydrocarbons, the input, the processing rate inside the water column, and then the output at the top of the system. And of course, part of this is a big part of our project is looking at surface oil slicks and the fate of those oil slicks, because during the Deepwater Horizon, a large fraction of the Gulf surface was covered by oil. Some of that oil settled to the bottom and damaged deepwater corals and myofauna and other things, and that happens at natural seeps too. So we can actually use the data we get from natural seeps to really understand what happened during the Deepwater Horizon. I think there's 3 threads. One is that microorganisms are pretty efficient under the right conditions, and if not perturbed by bothersome things, at oxidizing oil and gas and moving that carbon up the food web. And that's really important. That's an important finding. We saw that during the oil spill, but the fact that we also see it at natural seeps tells us that this wasn't a fluke during the oil spill. This is something that happens all the time. The second thing that I think is really important is that we've documented the sedimentation of oil. And we know now that it happens not just during oil spills, but naturally at a natural seep that's vigorous, you get sedimentation of oil to the seabed. But the impacts are different. The Macondo sedimented oil layer behaves very differently than the sedimented oil layer at a natural seep, and that's one of the things that we've documented, but we don't understand why that is. And the other thing that we're doing a lot of is trying to track recovery of benthic communities, and trying to understand how coral communities and myofaunal communities are recovering in the wake of the disaster. And the shocking thing there is that almost 7 years out, the corals are still showing damage. There was a phase where they looked like they were getting better, and now the damage looks to be increasing again. So there are acute effects, and then there are chronic effects. And I think we're just now getting to the point where we're starting to see some of these chronic long-term effects that were invisible, the first 5 or 6 years of the post-spill. But I think it's critical we need at least a decade's worth of data to really tell the story of recovery. Based on what we've seen, some things are just beginning to sort of eke their way back. And we need another 2 or 3 years to really nail that down. And I think we'll be able to nail it down.